Also in chapter 1, we talked about how to write and evaluate expressions using negative exponents. So when we're trying to eliminate a negative exponent in our final answer, you always want to make sure that in order to eliminate the negative exponent, you make it the reciprocal. So if you have a to a negative power, let's just pretend it's a to the negative x power. In order to eliminate that negative exponent, you create the reciprocal and you get 1 over a, and the power becomes positive. So if we look at example 12, if I need to get rid of that negative exponent, I need to create the reciprocal of x to the negative 10th, which is 1 over x, and then the power becomes positive. In number 13, you notice that we first have to apply a multiplication property. The property is when we simplify multiplication of bases that are the same. Now on the last video I said when you're multiplying bases that are the same, you add the exponents and then you simplify. So y to the negative third plus negative 2 is y to the negative 5th power. However, you never want to leave an answer with a negative exponent, and so you create the reciprocal and you do 1 over y to the 5th power. In example 14, it asks us to write with a negative exponent. Notice how I crossed out b and I rewrote the problem as 1 over x to the 9th. Okay. Let's look at a though, and we want to write it with a negative exponent. Usually in the directions it will also say to write with a negative exponent other than -1, which means I need to rewrite this 144 as a power itself. So 144 is 12 to the 2nd power. Once I have that denominator rewritten as an exponent, in order to write it with a negative exponent, I can write it using the reciprocal. The rule works for forward and backwards. So 1 over a to the x, I can get rid of the 1 over and just make my x negative. So this would give me 12 to the negative 2nd power. Whereas if I want to write 1 over x to the 9th with a negative power, I get rid of the 1 over and my exponent becomes negative itself. Okay?